Okay, so the first function is f of x equals 3x over x minus 1. If this could factor, that's what I want you to do, which is why I wanted to emphasize what the actual original function was. This is the original. If it can factor, in this case, the numerator or the denominator can't factor. And if it factored and then reduced, then I want you to reduce it. In this case, these are all one and the same, so it really doesn't matter all that much. To find the domain, we take the original function, denominator, and set it not equal to 0. So when I do that, I say x minus 1 can't be 0, so x can't be 1. The domain is all of the values that it can be, so negative infinity to 1, union 1 to infinity. To get the vertical asymptotes, I set the reduced function denominator equal to 0. Well, the reduced function and the original in this case happen to be the same, so x minus 1 equal to 0, so x is equal to 1. The vertical asymptote is written as x equals 1, which is a vertical line. And I'm going to go ahead and draw that right on my graph right now as well. Because none of the factors canceled at all, if you had any factors that canceled, you'd set those equal to 0 to get wholes. But notice, from the factored form to the reduced form, nothing canceled, and so therefore there aren't any wholes. Next is the horizontal asymptote, and the way we find that is to use our chart. We compare the degree of the numerator, and the degree here is 1 because that's the exponent. The degree of the bottom leading coefficient is 1 there as well. So because the degrees are the same, I'm going to take the leading coefficient of the numerator divided by the leading coefficient of the denominator, which is 3 divided by 1, which is just 3. To find the point crossing the horizontal asymptote, I'm going to take my reduced f of x and set it equal to my horizontal asymptote. So my reduced function, which is the same as the original in this case, and I'm going to set it equal to my horizontal asymptote. My horizontal asymptote in this case is 3, or 3 over 1. So I cross multiply and I get 3x minus 3 equals 3x. When I solve, I'm getting, let's see, negative 3 equals 0. Well, that's not solvable because there's no x's left. Therefore, there aren't any points crossing the horizontal asymptote. To find the x-intercept, I'm going to set my reduced function equal to 0. So we have 3x over x minus 1, and I set that equal to 0, and I cross multiply, and that's just 3x equals 0. Notice that whenever you set it equal to 0, really all you're caring about is the numerator equal to 0. So I'm going to come over here and erase my instructions. You can do it the long way, but I find if you just take the numerator and equal to 0, it's going to be a little bit faster. We're going to save ourselves a little bit of time. So we have x is equal to 0. I know x-intercepts are always something comma 0, in this case 0 comma 0. For the y-intercept, that's when we find f of 0. So I'm going to go ahead and use the reduced form here. So it's 3 times 0 over 0 minus 1, which is 0 over negative 1, which is just 0. So my y-intercepts are always 0 comma some value, in this case 0 comma 0. So looking at all of these steps together, it's kind of hard to know when to use the reduced form versus when to use the original. So the way I've come up with this to help you out a little bit is the only time you use the original is on the first step, the domain. Every time after that, if you always use the reduced form, it will work out. Okay? In some cases, you could use either the reduced or the original, but an easy way to remember which one to use is use the original for the domain, then reduce your function, and then use your reduced function for every single thing after that. Okay, so let's plot everything that we have here. I've got a vertical asymptote at 1, I've got a horizontal asymptote at 3, and I've got 1 point at 0 comma 0. So that's really not going to, it was only going to give me 1 point. But I can tell 1 point of that because I know I need to connect my line with a smooth curve, and the smooth curves have to get really, really, really close to your asymptotes. So the only way that that can happen is to get really close to your horizontal asymptote to the left and your vertical asymptote down. So that is how I connect my lines. There are points on the other side of the graph that I don't know where they belong. Notice that the domain goes from negative infinity all up until 1. We already have that part. This whole branch we already have graphed. What happens to the branch at 1 to infinity? Well, I don't know. So I need to figure out some more points. So I'm going to just go ahead and pick another point. So another point that I'm going to pick is to the right of 1. So I'm going to go ahead and pick 2. So I'm going to evaluate f of 2. And again, always use the reduced form. Unless you're doing domain, it's going to be a whole lot easier that way. So I'm getting 6 over 1, which is just 6. So I have the point 2, 6. So at 2, 6, I have a point right here. From that one point and the asymptotes tell you a lot of the picture. In order to get really close to the asymptotes, the only way the picture can look going through that point is the branch above the horizontal asymptote to the right of the vertical asymptote. So that is my picture. Now, there's one other thing that we could have probably figured out, that it should have been above the asymptote. We know that there's only one x-intercept because we found it over here, right? So if there's only ever one x-intercept, could our graph possibly be down here? Well, no. Otherwise, it would have crossed the x-axis. So if just using a little bit of deduction, I could have probably figured out that because it only crosses the x-axis once, that the other branch needed to be above the horizontal asymptote. So on this next problem, f of x equals 3x over x squared minus 4, we can factor the denominator. But even though we can factor the denominator, and now we have a factored function, nothing divides out. And so the reduced function could either be the factored form or the original function. We don't really have a different reduced form. The factored form and the original function are truly the same function. So it wouldn't really matter which one you use when we're called upon to use the reduced function. Either one will be fine because there is no new reduced function. To find the domain, I'm going to set the denominator not equal to 0, and this is with the original, although in this case they're basically the same. So I am going to say x plus 2 can't be 0, and x minus 2 can't be 0, so x can't be negative 2, x can't be 2. The domain is all the values that it can be. So negative infinity till negative 2, union negative 2 to 2, union 2 to infinity. The vertical asymptote is where you set the denominator equal to 0, and that's the reduced form. Again, it's the same because there is no real reduced form there. So I just set x equal to 2 and x equal to negative 2. And those are my two vertical asymptotes, and I can go ahead and put those on my graph if I want. The next part is the holes. Holes only appear if you cancel a factor out. And you would set those canceled factors equal to 0. But there was no canceling, so therefore there are no holes. The horizontal asymptote, that comes from the chart. The chart where I compare the degree of the numerator, which is 1, to the degree of the denominator, which in this case is 2, because that's the exponent. Because the denominator is larger, the chart tells me that my horizontal asymptote is y equals 0. I'm going to go ahead and put that on the x-axis there as my horizontal asymptote. Next thing I want to do is find the point crossing the horizontal asymptote. The way I do that is I set the reduced f of x equal to the horizontal asymptote. So I'm going to come over here and set my reduced function. Now, it could be either the factored one or the not factored one because we never really canceled anything out, so therefore we never made a new function. I'm going to go ahead and use the unfactored form, and set it equal to my horizontal asymptote, which in this case happens to be 0. When I cross multiply, 0 times the denominator is 0, 3x times 1 is 3x, so I solve and I get x equals 0. Okay, because I got x equals 0, that tells me I do have a point that's crossing the horizontal asymptote. And so I take this x equals 0 and that goes in for the x coordinate. The y coordinate comes from my horizontal asymptote. So I have a point at 0, 0 that truly does cross the horizontal asymptote. Now, the x-intercept and y-intercept, you might be able to figure those two out just by looking at your point crossing the horizontal asymptote. 0, 0 is an x-intercept and a y-intercept. I'm going to go ahead and show you the work, but if you can look at this and realize that both of these answers are already going to be 0, 0, that might save you a little bit of time. To find the x-intercept, we set the reduced numerator equal to 0. So I'm going to set 3x equal to 0. You could set the whole function equal to 0, but if the numerator is 0, then the whole function is 0. So just setting the numerator equal to 0 is going to save you a little bit of time. So x equals 0, so that's going to be my x-intercept. My y-intercept, I have 0, some value. In order to find that value, I'm going to find f of 0. Again, that's the reduced form. In this case, there isn't a reduced form, so I'm just going to go ahead and use the original f of 0. That was 3 times 0 over 0 squared minus 4. So that's 0 over negative 4, which is 0. So 0, 0. Again, not such a big surprise. We probably could have figured that out ourselves. All right, so we've plotted everything we can, and we actually don't have a very good picture of what's going on here. So I need to pick some more x and y values and plug them in. I need to know what's going on the left side of the graph. So I'm going to pick something to the left of my vertical asymptote. So I'll pick negative 3. That's either going to tell me if my graph's down here or if my graph's up there. I'm not sure which one it is, so I'm going to have to plug in a point, negative 3, and find out. So when I plug f of negative 3 in, I'm getting negative 9 in the numerator over 9 minus 4, which is 5, so negative 9/5. Negative 9/5 tells me that my point is down here. Negative 9/5 is like almost negative 2, not quite. But that one point tells me the rest of the picture. With that one point and my asymptotes, I know I have to get really close to both my vertical and my horizontal asymptotes without crossing them. So that's the only way that the picture can look, just with one point. I also need to know what's going on to the right of my vertical asymptote too. So does the branch is up there or is it down there? I'm not sure. So what I'm going to do is I'm going to plug in 3. So let's evaluate f of positive 3. So I'm getting 9 over positive 5. So 9/5, positive 9/5. At 3, positive 9/5, I have a point above the horizontal asymptote, and I know I don't cross the horizontal asymptote anywhere else, so I'm going to get really close to both my vertical and my horizontal asymptotes, and that's going to be that branch. Okay, so in the middle here, there's a lot of things that could be going on here. Don't write this for a moment, okay? The graph could come from the top, and then it could turn around, or it could come from the bottom and turn around. Well, we don't know. It could also come from the bottom, cross, and then go to the top, or it could come from the top, cross, and go from the bottom. So there's lots of different ways that we could graph this, but there's only one correct way. So what I need to do is I need to find out more information here. So let's find something to the left of my point crossing the horizontal asymptote and one to the right. So I'm going to plug in f of 1 and f of negative 1. So I plug in 1 and I get 3 times 1 over 1 squared minus 4. So that's 3 over negative 3, which is negative 1. So when I plugged in positive 1, I got out a negative 1. Now I'm going to plug in a negative 1, which gets me negative 3 over 1 minus 4, which is also negative 3. Negative 3 divided by negative 3 is positive 1. So at negative 1, I have a positive 1. So that tells me the rest of my picture. I know that because to the left of my point crossing is going to go up, it's going to have to continue to get closer to the horizontal asymptote, and to the right of my point crossing, it's going to have to go down towards my vertical asymptote. And so I have now completed my picture.